In the same way that we can find mean for discrete random variables, we can also find the variance and the standard deviation for discrete random variables. The formula for finding variance is sigma squared sub x. Remember that the mean had the mu sub x. This is sigma squared sub x. And what we're going to do, there's two different ways we can do this, is we have each value minus the mean squared. This time we're going to take it times its probability. Remember before when we were finding the variance, we did the value minus the mean, squared it, and we added them all up. Well, this time, instead of dividing by n, what we're going to do is we're going to take each one of those and multiply it by its probability. There is a second formula that we can do. We can use the formula sigma squared x sub x is equal to the sum of each x value squared times its probability. We add all of those up, and then at the end we subtract out the mean squared. Either one of these will work. This one we just have to remember to subtract out the mean squared. This one we would set up a table just like we did previously, finding the regular standard deviation and variance. Whereas this one we would have to square each x and then multiply it by its probability, remembering to subtract out the mean at the very end. Now, standard deviation is going to be the exact same, except for it's sigma sub x, and we just take the square root of the variance. So let's look at an example of this. And when we're looking at the example of this, we have the following probability distribution for the age of a student at a certain public high school. So we have ranging from 13 to 18 and their probabilities. And we want to compute the variance and standard deviation of the ages. Well, no matter which formula you use, the first thing that you're going to have to do is compute the mean for the distribution. And so the mean sub x, let me write that a little bit clearer. Mu sub x will be 13 times 0.08 plus 14 times 0.24 plus 15 times 0.23 plus 16 times 0.28 plus 17 times 0.14 plus 18 times 0.03. And so we get 1.04 plus 3.36 plus 3.45 plus 4.48 plus 2.38 plus 0.54. We add those up and we get that the mean age in this particular high school is 15.25. Remember that when we are calculating and using the mean for the variance and standard deviation, we do not want to round the mean. And so I've already set up this table to work with for us to help us organize this. And so this is similar to what we were setting up with our table on variance and standard deviation before. We have our value. We have our value minus our mean minus our mean squared. The difference here is we add these last two columns, our probability, and then our probability times our deviation squared is what it is. And so here, what I'm going to do is I'm going to take 13 minus 15.25, and that's going to give me a negative 2.25. And I'm going to do that all the way down. So 14 minus 15.25 is going to give me a negative 1.25. This will give me a negative 0.25. 16 minus 15.25 will give me a positive 0.75. This will give me 1.75. And 18 minus 15.25 will give me 2.75. In my next column, what I'm going to do is I'm going to take my answer, negative 2.25, and I'm going to square it. Now remember that when you square that, notice it is in parentheses, so that means that it's a negative 2.25 times a negative 2.25. So these will always be positive numbers in this particular column. Do not round any of these numbers at this point. You do not want to round anything until the very end, if possible. So I'm going to get 1.5625, and that is taking my negative 1.25 times a negative 1.25. Then I'll take a negative 0.25 and square it, and I will get a 0.0625. Again, that's taking negative 0.25 and squaring it. If I take a 0.75 and squaring it, I will get a 0.5625. Let me write that a little bit plainer. I get a 0.5625. 1.75 squared will give me a 3.0625. And then a 2.75 squared gives me a 7.5625. Now this column, I'm just going to write in the probabilities that were in the probability distribution up here. So I'm just going to recopy those in this particular column. So it's going to be a 0.08, a 0.24, a 0.23, a 0.28, a 0.14, and a 0.03. This last column, what I'm going to do is I'm going to take this third column times the fourth column. So I'm going to take 5.0625 times 0.08, and I will get a 0.405. I will take 1.5625 times a 0.24, and I will get 0.375. I will take 0.62, that should be a 0.625 times a 0.23, and I get a 0.014375. Notice, I'm not rounding anything. I don't want to round anything until the very end. And I'm going to take a 0.5625 times a 0.28, and I get a 0.1575. I'll take a 3.0625 times a 0.14, and I get a 0.42875. And then I'll take the 7.5625 and multiply it by the 0.03, and I get a 0.226875. To find our variance, it is these numbers added up. So sigma sub x squared is going to be these numbers added up. So 0.405 plus 0.375 plus 0.014375 plus 0.1575. Let me scroll over just a little bit. Plus 0.42875. I need to scroll over a little bit more. 0.226875. So I'm going to add those up, and that looks horrible as a sigma. And sigma sub x squared is equal to 1.6075. So once you have your chart laid out like this, your variance is just totaling up this last column. And then, of course, your standard deviation, sigma sub x, is the square root of your variance. So that's going to be 1.2679. And at this point is where we could do the rounding and get that the standard deviation is 1.3 and our variance is 1.6. Again, we do not want to do any rounding until we have finalized all of our calculations. So what I would like for you to do is practice some of your variance and standard deviation, and then let me know if you have any questions.